Section 4.1, exponential functions. This is part 3. There's 4 parts. I wanted to have short, less than 10-minute videos that you look at versus one that's like an hour long. That's a little bit too much and not as effective. Okay, so this is part 3. After part 3, you'll have one more, part 4. We've been talking about graphs of exponential functions. With graphs of exponential functions, we first look at the base. If it's a base that is greater than 1, we have a graph that increases. If we have a base that's a fraction, we have a graph that decreases. Notice whether or not our graph increases or decreases. Each of these graphs go through the point 0, 1. What else did we learn? We learned that the domain, no matter what, it's a given. Domain is all real numbers, but we have to be careful with the range. If there's a transformation like up, down, or reflecting, say, on the x-axis, the range is going to change. Okay, so the range depends on the function that you're working with. Y equals 0, or the x-axis, is your horizontal asymptote. And that was a basic graphs that we started to look at. As we work with these, we want to have an idea of what the graph looks like, review our transformation rules, and that helps us apply what we know. Graph the function not by plotting points, but by starting from the graphs of figure 2. And so these are the graphs of figure 2. We just want to remember a greater than 1, increasing, a is a fraction, so we got decreasing. Okay, so we're going to graph not by plotting points, but looking at a basic graph along with transformations. Then we're going to also look at domain, range, and asymptote. Okay, so let's look at a basic graph. What graph is our basic graph? Our basic graph here is 3 to the x power. Okay, so what does 3 to the x power look like? 3 to the x power goes through the point 0, 1. If I take 3 to the first, 3 to the first power is 3. If I take 3 to the second power, we get 9. We'd be somewhere maybe up here. And then if we took 3 to the negative 1, 3 to the negative 1 would be a third. We're pretty close to that x-axis. That's our basic graph, 3 to the x. Okay, so what we want to know is, looking at that basic graph, how can we use it to graph h of x is equal to 6 minus 3 to the x? We'll start with that basic 3 to the x graph. We're going to work this transformation. What is it? Reflect on or flip on the x-axis. And then, since we added 6, we're going to move our graph up 6 units. Okay, so transformations. Try to do any stretching or shrinking first. Then you're going to do any reflect or flip on the x, flip on the y-axis. Then you do up, down, left, right moves. So we need to start with flipping on the x-axis first. Okay, so that would come down here. We'd be at 0, negative 1. Here we would have 1, negative 3. X-axis is still our horizontal asymptote. Okay, so this only works on flipping the 3 to the x graph. Okay, so next we need to move that graph up 6 units. Okay, so let's take this point and move it up 6. 1, 2, 3, 4, 5, 6. There would be our new point at 5. Let's take this point and move it up 6. 1, 2, 3, 4, 5, 6. We're going to also take the horizontal asymptote, which is the x-axis, and we're going to move that up 6 as well. So instead of at y equals 0, we're going to be at y equals 6 for our new asymptote. Okay, so let's shift this up 6 units. We're going to end up with a graph that looks like this. Okay. There is our graph. H of x is equal to 6 minus 3 to the x. Okay, state the domain. Domain automatic, negative to positive infinity. Range, what y values occurred after we flipped and moved our graph up 6 units. Okay, so here's our y values. Y values start at negative infinity and go up 2, but doesn't touch or cross 6. So negative infinity to 6 is what we get for y. Okay, asymptote. Okay, so this was y equals 0 originally. Our new asymptote is now at y equals 6. And there we go. We have the graph of the function, we have the domain, range, and asymptote.